We're going to wrap up our unit on modeling data with a lesson called Rocking the Residuals. In this, we're going to learn how to use residual plots, find out what those are, to help us analyze the strength of a linear model. So we've talked about correlation coefficients. We'll look at another thing that helps, which is known as the residuals. So here's a scenario. The correlation coefficient I talked about is not the only tool statisticians use to analyze whether or not a line is a good model. They also consider residuals, which is to look at the difference between the observed value and the predicted value. Sounds a little complicated, but it isn't really. The residuals are just a way of thinking about how far away from the actual data is from the regression line. So here's the data. Here's our scatter plot. Points are graphed on the graph here. And here's the regression line, y equals 3x plus 6. So in order to find the residuals, we want to find how far away each point is from the regression line. So we draw a line straight down or straight up, and we figure out how far away they are. So you can kind of use this and see, well, these points are pretty close. This one's a little further off. This one might be an outlier. And we should be seeing about half the points above, half below. So another way to help us organize this information is to create a residual plot. The way we create a residual plot is we need to calculate the residuals. And in order to do that, we need to compare how far off we are from the predicted values each point is. So how do we calculate the length of each segment? Well, how are we going to figure out where this point is? Well, the y value here is 10. So what I can do is figure out where, how far away I am from this line. So I put those on Desmos to help me out a little bit more. And what I'm going to do is take a look at how far off these points are. So if I'm looking at this point, 110, and I've got these different values here, I want to see how far off I am. So one way to do that is to calculate, I could substitute, if we go back to our equation, so our equation is y equals 3x plus 6. Well, I can figure out, what am I supposed to be at 1? Well, if x is 1, 3 times 1 is 3, plus 6 is 9. Excuse me, 9. So my y value should be 9. I had 10, so I was 1 higher. So actually my residual, I can make a table here. My residual is 1 higher when x is 1. So we can do the same thing for all these values. When x is all the way up through 6, find out what it should be. So I'll go back to my calculator. So when I'm at 2, it's 13. It's supposed to be 12. So I'm 1 off, 1 higher. At 3, it was 7, but it's supposed to be 15. So I was 8 under. So that residual would be negative 8. So you can finish calculating for 4, 5, and 6, and then you're going to graph those residuals on the number or in the graph here. So go ahead and do that. Pause the video, restart it when you're ready to get going and see what I had. Okay, so that's what I got from my residual table. Those are my residuals when x is 1 through 6. Somewhere above, somewhere below, and when we graph it, it becomes more apparent. And like I said before, a residual plot should show about half the points above, half below if it's a true line of best fit. And we can kind of get a trend of how the points are going. Is this actually the best fit or not? So we'll take that residual plot, and actually let me show you something pretty neat here. So on Desmos, in our linear regression, we've got this thing that says residuals. Oh, you know what that is now. So if I click plot, it's going to plot my residuals for me. And notice those are listed here on my table. I didn't even have to do any calculations if I didn't want to. So it's going to calculate that, and that helps out when you've got an equation that isn't real nice and neat. Our equation is y equals 3x plus 6. Those are easier to calculate. And then it gives us our residuals on the table, and then it plots them for us. So here we see our residual plot that we did by hand before. So that's something helpful that technology can help us save some time doing to help us make our analysis, make it easier to analyze that. So now we've got some questions we'd like to consider. So now that we've constructed that residual plot, let's think about what they mean and let's answer these questions. So take the time to read through 4 through 7 and answer those questions. And then you're going to take a look at these graphs, 8 through 11. And these are residual plots. So as I mentioned before, statisticians look at residual plots and see if there's patterns in the data that are not predicted by their model. What patterns can we identify by these residual plots? And what might it indicate about the regression line? That it's probably not the best model for the data. So based on the residual plot, which points also could be considered outliers as well. So take the time to look through those graphs and answer those questions. What do you observe and notice? And then we'll go through it together. So pause the video now and restart it when you're ready. All right, so as we look to understand what residuals are and what they tell us, we had a couple questions. So here's some of the answers that I came up with, and you can compare it to what you had. The first one, if a residual is large and negative, what does it mean? Well, that shows that the actual data point was well below the regression line. It could be an outlier if it's a very large negative number, but negative means it's below our line. Positive means it would be above. The smaller the number, the closer it is to the regression line. Excuse me. What does it mean if the residual is equal to 0? Well, it means the residual is right on the regression line. If someone told you that the estimated line of best fit for a set of data points and all the residuals are positive, what would you say? Well, you'd probably think that that line of best fit was wrong, because the line of best fit should have about half the points above, half below. So that line of best fit was too low. If the correlation coefficient for a data set is equal to 1, what will the residual plot look like? If the correlation coefficient is 1, that means all the points are dead on. So all the residuals would be right on the line, and so all the residuals would be 0. So in that case, your residual plot, if we're looking at it, all the points would be on 0. So it won't happen too often when we're looking at data, because data doesn't work out nice and perfectly, but we need to understand what that means. So then you're supposed to take a look at these graphs and try to find some patterns. So notice in the first one, about half the points above, half below. That's a good fit. But notice as we go from left to right, as the points go on, they're getting further and further away. So since the residuals are increasing, we see that everything's pretty balanced. So our correlation might be good. Our correlation coefficient could be good. But maybe it's not a good linear regression. Here it's pretty good at the beginning. The points are pretty close, but now they're getting further away. These points right here are now getting further away as we move away as we go left to right. So, maybe a linear model isn't so good at the end there. So maybe a linear model is not the best fit for the whole set of data. Number 9, notice we've got this kind of curved pattern. First the points are below, then they're above, now they're below again. That might indicate that a linear model is probably not the best. On our previous one, we had our points pretty much spread evenly, and this would suggest a good linear model. Whereas here, when it curves, starts below, then above, then back down, quadratic or maybe even exponential might be a better fit. Here we see they're scattered pretty evenly at the beginning, similar to our first one, and then they jumped up later. But here, that would maybe suggest a good linear model, but notice they alternate: negative, positive, negative, positive, negative, positive, negative, positive, negative, positive. So, maybe we're missing some other pattern in the data that suggests that, a linear model is probably not the best fit. And maybe it's, if it's alternating like that, there might be a better pattern to it. Then finally, number 11, we'd say, wow, this is a pretty good fit. The data is spread pretty evenly. It's very close. And we got this one right here. We'd have to say that's an outlier. But otherwise, it's a good fit, and we say that's a good linear model, and that would have a very good correlation coefficient as well. So, as we talked about the lesson, we learned that not only is correlation coefficient a good thing to look at, but statisticians also want to take a look at the residuals. So, something to keep in mind when you do your regressions is also add in that residual. Look at the correlation, look at the coefficient, 0.709. It's close to 1, the better. But then also look at these residuals. Notice these are getting further away. That kind of explains that maybe it's not always the best fit. So 2 things to consider as you're looking at regressions. Your assignment you're going to be looking at in class, continue looking at spread of data using box and whisker plots, answering questions about those, and then working with residual plots and correlation coefficients. So you're going to work on marking the graph where this means the average of x and average of y. So find that middle point on the line, create residual plots, and then predict the correlation coefficients. And then you're going to finish up by analyzing residual plots and determine whether it's the best fit or not. So that's all we have. I can answer any questions you might have in class.